Hello everybody, we're going to go through part B of your engineering product design and manufacturing exam. Now this is a past paper. Please do not expect that this is going to be the paper that you're going to work on. We don't know what that is yet because it's not been issued. So the format you should be familiar with. The format, if you've not seen it before, you'll be familiar with that. And we're going to go through it. Now, general crack, as you always do, you're not a stranger to exams. You need to put your names, your centre number, and your learner number. It has to be put on here. Right. So the first page is some spiel that you should read. Second page is some information for the tutors. The third page is the outcomes for submission. So this is what we expect to come from there. And your fourth page here is instruction for the learners. Have a quick read of that, and then you'll have a reminder of Part A set task brief. So this is what you've done on your research task. Page 6 on this particular one is Part B set task information. Don't worry if you can't see it from there. I'm going to use my other camera to go in there so you can see this is what goes through here. We're now going on to Part B of the exam paper. We're going to concentrate on activity 1, but when you come into the exam, please make sure you get your research task sheets. Make sure they're present for you. If they're not, ask why. Please make sure your exam sheets are in. Quickly read through the first few pages, which is what you see here, page 1, 2, and 3. So I'm not going to go through those as we go through here. There's some instructions for you to go through here. Obviously don't break any rules, as they say. And this is just a recap of what you've done here. So page 5 is a recap of what you've done. This page 5 is a copy of the sheet that you worked on for your research task. Here's your set task that you got. So the main thing that you need to worry about is that you read through this carefully and thoroughly. Don't just skim read it because you'll miss detail there. Page 7 is some clear instruction saying the shelving unit must. So you will see this on your exam that you have. As I say, I don't know what it is, but you will have instructions. The shelving for this one, it clearly states the shelving unit must. So we're going to tackle this how you would tackle your exam. There's some easy points to win, and there's some difficult ones where you'll have to put some thought into it to create the best, let's say, the best material for your exam. There is a table that it refers to, table 1. There you go from there. And here's the activities. Now, they were kind enough to actually suggest the time for each activity. So without further ado, just make sure you record all these times. Right, just looking at the Part B set task information. Make sure you've got a pen or a highlight. So just going through this one. And just get the camera in the right place. Obviously, you'll be reading this bit here. Basically, it says the shelving unit holds heavy casters that need to be stored before further processing. In addition, the shelving unit can be located inside the factory and may sometimes be moved outside. Okay, so the client is aware that the current design for the shelving unit has a number of issues, but the redesign has been triggered by feedback from the users about the shelving rods bending or breaking, meaning that the unit becomes unusable and dangerous. User feedback is that the shelving unit is not effective for several reasons. So just looking at that bit there, we need to make sure we underline this. So, but the design has been triggered by the feedback from the users about the shelving rods bending or breaking, meaning that the unit becomes unstable and dangerous. So just underline those ones there. User feedback is that the shelving unit is not effective, and for several reasons. And it comes up with a list here. The client believes that the source of the issue is that the current shelving unit can be unstable. So again, it's repeating it. It wants to sort out stability. And why is it unstable? It bends and it flexes. So in there, this part here needs to worry about this one here and this one here. Okay, bends and flexes. Is it robust enough to hold the mass of the castings being placed on it? Well, you can actually, if you remember what I said on the previous video, there's nothing holding it together. So if you put anything on it, it will just fall apart. So that's what I'm seeing from there. So it's telling you that it's not robust enough. So you need to make sure that your design is robust and it can hold the mass of the castings being placed on it. They also say that it's difficult to assemble and disassemble. Okay, that's difficult to, so make sure you get that. And it's often damaged and misused. Why would you think that? Well, let's put it this way. If you've got something that's useless, you're more likely to throw it on the side and not want to use it. Okay, so if it's damaged and misused, it's because it's a poor design. I really want to say crap, but it's a poor design. And if you're using something like that, it's like you have some break on there. What do? You know, people lose their temper and just throw it, and that's what they've probably done with this as well. And it makes it difficult to place and pick up some of the castings. There's 3 shelves on it, so why is it difficult to place and pick up some of the castings? Okay, why is it difficult? So think about how you can tackle that. If we look at this one, sometimes the issues also result in damage to the castings that are held on the shelves. Well, we know the shelves are made out of metal, so issues result in damage to castings. Okay, the client has stated that the number and overall size of the shelves must remain the same. I would put a ring around that. This is a constraint. That's what they want. It comes with 3 shelves. You give them back 3 shelves. It gives you a full width and the length. You have the same one. Based on the test, the client has provided information in table 1. So there is a table here somewhere. Oh, let's have a look. Here's table 1. We'll come back to that. I think that's on a further task. I'll go from there. And which can be used to perform statistical analysis of the in-service use of the shelving unit. The client had intended life cycle of the shelving unit to be 5 years. That ain't going to last 5 minutes. So that's what you've got to do. Make a unit to be 5 years. Life, right, let's put that in square bars. Life cycle will be 5 years. Okay. At the moment, I don't think you're getting 5 minutes. The client has asked you to design an alternative solution for the shelving unit that will take into account the most efficient use of materials. Now, this is where we're going to start having a little bit of lumpiness. Efficient use of materials. Can you see that one there? And manufacturing processes. Hopefully you know what that means. In effect, that is going to be cheap. They want cheap. Okay, so nothing gold plated in that business. You should optimize the design in terms of safety. They've already said about here it's unstable and dangerous. Form, okay, sustainability, and other factors. Okay, now in your research notes you should have something about safety of producing shelves for the user, manufacturing, and something like that. Sustainability, you should have something of that on the manufacturing processes or design engineering. You also have the opportunity to reduce the issues with the existing design of the shelving unit, considering the equipment interfaces and using extra low-cost components. Again, cheap is coming to this. That's what they're after. Cheap. If it's going to cost 500 quid to make a shelf, they're not going to happen. If it's going to cost around 25 to 30 quid with the manufacturing process you want to employ, they will probably buy it, which is a good outcome. Most shelves of this sort of thing is, if I can remember rightly, you can pick a fairly cheap boltless system for a good 30 to 40 quid, easy. On page 7 on this particular one, they've actually stipulated the shelving unit must. So whenever you design, it says must. 3 shelves that are 1000mm long and 400mm wide. You must have those. Allow castings of different sizes and masses to be placed easily and safely onto the shelves, stored and then removed from the shelves. Allow castings to be of different sizes. Allow different sizes and masses to be placed easily and safely onto the shelves, stored and then removed from the shelves. This is an important one. Be easy to assemble and disassemble so it can be moved. Assemble, disassemble, that's the main word, easy. Okay. Be robust enough to last the intended life cycle wherever located. Robust enough. And be capable of manufacturing in batches of 1,000. Manufacturing batches of 1,000. So you need to make sure that if you don't underline or ring anything, you probably just overlook it and go from there. So when you read thoroughly, you can have a good list of things that you need to include, or you might want to include in your design. We have table 1. We shall come back to that later. And now they list the activities. There are 5 activities. 1, 2, 3 here. 4 and 5. I want you to take notice that they suggest a time for each activity. So activity 1, which is give you 6 marks, is 45 minutes. Activity 2, another 6 marks, which is another 45 minutes. Activity 3, 9 marks. They're expecting 1 hour 15 minutes. And then you've got the big kahuna here. You see here. Activity 4, which is 30 marks, which is a suggested time of 4 hours. And the final one, which is activity 5, which is 9 marks, which is a suggested time 1 hour and 15 minutes. Activity 1. As you can see here, at the start of the activity, create a short outline project time plan in your task booklet. During the other activities, 2 to 5, you should also record in the activity 1 section of your task why specific changes were made to the design during each session, specific action points for the next session. So for activity 1, let's deal with create a short outline project time plan. Okay, now remember, I did say they suggested times on these sheets here. Obviously, you're not going to take your booklet apart. They suggest times on here, and that's what we're going to do on here. We're going to use that exact information here, on here, and we're going to create a table that's going on here. Activity 1. We're going to concentrate on creating a short outline project time plan. substantial time plan here. Again, it's got activity, I've added description, time allocated, actual time taken, marks for each section that you see there. Now what I've done, I've just done the first two so you can see how quick it is. Now your writing, if your handwriting is terrible, you need to try and slow it down a little bit, or try and print it out like this. I'm trying to write as fast as I can. I've not fully detailed activities 3, 4 and 5, but what I have done is add a sixth one, which is a quality check. You're going to have to give yourself 15 minutes at the end of the session. So the biggest one is the 4 hours that you have here. I've subtracted 15 minutes off that, put a new time on there, and give myself 15 minutes here to check through your work as we go through. You're expected to do that. It's good practice to do that. If you're running right to the end, you've done no checking. So just use this time here. Now, if you like, if you want, do a quick check after each activity as you go through. But then again, if you see this is what you're doing. So as you see here, this is a short outline that should cover in better detail of what they've actually asked for here. And bear in mind, this is not all the 6 points. The other points are going to come from here. Is that you should record in activity section 1, which is this one here, what you've done in each section. So if you're doing section activity number 2, as you go through it, record what you've done through here and what is to do for the next section. And then when that's complete, activity 2 complete, activity 3, what time you might as well write in there what time you start and something like that. So activity 3, so this would be you might as well write duration, and we've only got 45 minutes for this one, 45 minutes for that one, and then you can then put the duration here. So you're just recording everything, so when you come down to filling in this last column, actual time, you can actually write the duration that you've done. You can't really put anything in here because you're going to continually do that. So if you take and create time plan, and let's take you 10 minutes, just put 10 minutes there and just add them up. 10 mins that you've taken so far, and then move on to the next move on to the next activity, and then hopefully all the little snippets that you've done recording each one should end up adding to 45 minutes. That's an easy one. Activity 2, as you can see here, interpret the client brief into operational requirements, to include product requirements, opportunities and constraints, interpretation of numerical data, key health and safety, regulatory and sustainability factors. You've written this briefly in this bit here. If you write that briefly in there, that's the description, or that's the description of activity 2 and so on. So you've got that covered. Thorough is key. So product requirements. So you remember hopefully remember that I've underlined all these bits and pieces that we went through here as I read through it, and then this one here, the shelving must, as you can see there. Now, easy one to start off with is that this is going to be your first hit. So in here, so bullet point number 1, so what I've done there is product requirements. So you're addressing bullet point number 1, so it's a lot. So basically what you don't want to do is have the examiner searching for your work. If you put that bullet point there, product requirements, just repeating that one there, and then everything that you offer is under this bullet point for product requirements. So we're starting off with this page here. If you can see all the circles that I've put in there that I've gone through on the video, you'll then just list those. So I'm not going to write everything down, so you're just going to list those. see that, have 3 shelves at 1,400 mil. Okay, that's the requirement for 6. On the top line, see that? Basically, you can expand that list. That was started there to include as much information that we have here. Okay, I'm not going to write it all down on here. You're going to do that yourself. Opportunities and constraints that you see here. Now, hopefully, I'm just going to go back to the opportunities and constraints. You may not have any ideas at the moment here. Just leave this. Just leave a space for it and then come back to it. Okay. Interpretation of numerical data. Now this is the key thing that they're after. It says interpret the client brief and your operational requirements to include. So opportunities, constraints. So you're going to obviously product requirements. You're going to finish all the list that you've got there. Opportunities, constraints. Okay, just add that bullet point. Leave it blank for a little bit, and then you're going to come back to it. Product requirements, as you see here, you write the full list, exactly what it says. Write this as best as you can to cover that. But remember the list, the first list here, is that the product requirements needs to cover all these issues as well. What they want from this, the shelving unit must. And the other requirements that you need is all the parts that you see here that must be covered. Just remember, they both go together. So just a little bit there, just to recap this one here. So product requirements, first bullet point here, product requirements there, the shelving unit must, and just write the list that you have from here, that all the highlighted parts that you want to include, and then you write the full list of that. Also refer to the previous page, write a list of issues you need to cover. They give you a list of issues. Okay, the client believes that the source of the issues that are the current shelving unit, and you cover those as well. If you've underlined them, make sure you cover their product requirements. That's the primary one, and this is your secondary list of requirements that you have to cover. Opportunities. And constraints. Opportunities, constraints. If you're not sure what to write about that there, leave it blank, but the opportunities will become apparent as you go through it, but the constraints are, they've already told you, 3 shelves, that's the size of it, and if you look through this bit here, there's other constraints that are after. Okay, so just read through it. So if you look at it, that efficient use of materials is going to be one of them. The manufacturing processes is also included, that efficient there. You optimise the design in terms of safety, performance, sustainability and other factors, so you need to cover that bit there. And the opportunity to reduce, so there we are, we just found this, the opportunity to reduce issues with the existing design of the shelving, so you now can incorporate that in there by considering equipment interfaces and using extra low-cost components. And there, that's another constraint, low-cost components. So it gives you a list of opportunities here, and it also gives you the constraints here, and plus other bits and pieces there. It's how you interpret. I can't tell you everything. I don't know what you're going to be ending up with as well. So that's that one there. We've covered the product requirement, so we should have a full list of what the customer wants. That's the shelving must. Opportunities, constraints, the opportunities there that you'll see that what you've underlined, okay, and also it says that you have the opportunity to reduce the issues with the design of the shelving unit by considering equipment interfaces and using extra low-cost components. Okay, so that's a constraint. The actual size of the shelves is a constraint. What is this? So we're going to cover interpretation of numerical data. This is the table that we've given you. Okay, now you'll see that shelving unit number here. So there's 6 there. Shelving unit materials, so give you a selection of materials. So you go carbon steel, stainless steel, aluminium alloy, and surface treatment that you see here. That is going to be spray painted, polished, anodized, and so on like that. And test location, inside or outside. Now it's important that they tell you the amount of weight that each one has. So they give you for each test how much weight it took, and the life cycles, the life cycle to failure. So when the shelves give up the ghost, in months that you see here. So test number 1 for this bit there, you can see those values there. Now how do we interpret that the most effective way? Here's one I prepared earlier. Okay, so looking at this, table 1, there are 3 materials used with different finishes. Stainless steel is polished, the aluminium is anodized, and the mild steel is spray painted. Okay, so you can see that from these first 2 columns. Okay, so you're interpreting that. So you're just repeating as you read it. You're just repeating what you're pulling out of that table. If you read this one here, 6 tests were conducted on each material configuration. Both inside and outside tests were done. Okay, again you can see the test location, which is inside and outside there. A range of loads were used on each configuration, ranging from 80 to 105 kilograms. How did each perform? So the aluminium shelf, so you're just drawing the information here. The aluminium shelf outside on average lasted 3.83 months. Okay, how did I do that? Aluminium shelf on the outside, you just add that lot together and divide by 6 that you see up there. That gives you the average. Now on the inside, on average lasted 4.33 months. So you get your overall results there. Stainless steel shelf on the outside, on average lasted 3.25 months. Actually lasted less than the aluminium one there. So you interpret as you go along. On the inside, on average lasted 4.5 months. A little bit better than the aluminium one. And if you look at the mild steel one, on the outside, on average lasted 1 month. On the inside, on average lasted 1.66 months. So you can see that is the worst one. So if you summarize this, stainless steel performed best on the inside, aluminium performed best on the outside. Mild steel lasted around a quarter of the other 2 materials. So you're just summarising that. Now there's enough information there that you've interpreted on that one there. So if you do get a table like this, that's fantastic. If you get a graph, you're going to need to start counting the odds and sods there. Now that's going to cover your interpretation of numerical data that you see on that bit there. The last bit, now during your research task, you should have noted something on key health and safety of shelving units, regulatory of shelving units, and sustainability factors there as well. So you'll draw that from your research notes. People, that is technically all the task 2 done. It doesn't take long to do. You just have to write fast and make sure it's legible. If you can't read, if the person can't read your writing, you're going to lose marks. So to make sure it's legible and keep it neat. So once you completed this one, let's say we took 35 minutes on that one there. I would return. See where my pen is. There it is. I messed up here. So we return for this one. So that one there, we can say that took 35 minutes. And just put in just put in a circle. I have 10 minutes. 10 minutes there. So you've got 10 minutes there. You need to watch the clock. So if I take 35 minutes to do all that lot there, that covers that. People, that'll be enough for tonight. So this video that I've created today will cover activity 1 and activity 2. Now remember, it says record. During the other activities, you should record in activity 1 section. You'll put why specific changes were made to the design during each session, specific action points for the next session. Okay. Now there wasn't no changes to any designs because you've not done anything. So I would put in there no changes to design because no designs were made, and then any action points you want to deal with. If there isn't anything, say task 2 activity is now complete, and then leave it at that, and then we'll move on to the activity 3. Little shout out for Jake Ross for spreading the word at the college. Thank you very much for that. Hopefully you'll get the next video out for tomorrow. Time is tight, I know, but you know, everybody's cramming in revision. Right, we'll go through activity 3, which is the production of the initial design ideas. More on that tomorrow though. Okay, over and out. See you all about.